All right, this is the last section of 5.5. It's titled Additional Identities. Basically, there's two things. We're going to go from product to sum identities, which these are actually the top right corner of your salmon sheet. And then we're also going to hit the sum to product formulas, which is the middle bottom column as well. So just kind of recognize that these four are on your salmon sheet. You got to make the connection and write down the formula that you need to write down for the given scenario. Okay, so on this one, it says rewrite it as a sum or difference depending upon what's going on. Now, what you need to kind of notice here is I purposely put 10 times your product. Okay, this 10 is nothing in. You don't have a number out here, so this kind of just tags along with you. So I know this answer is going to be 10 times whatever the sum formula is for a sine times a sine. Okay, so kind of go over here. Which one gives you sine and sine? It becomes your bottom one there. All right. And it actually is different on yours. It's going to be the top one on your salmon sheet, so they're not in the same order. But it's going to end up being 1/2. Okay, and then in brackets you have its cosine of a minus b minus cosine of a plus b. Okay, so these are available to you. What is a and what is b is the big question. Well, a is the first angle, b is the second one, depending upon what you have going on. Okay, so I end up going 10 times 1/2. You guys all know that that's 5. Okay, and then I'm going to go in brackets cosine of a minus b, 5x minus 3x, minus cosine of a plus b, so 5x plus 3x. That's what's in my brackets. And now you just simplify inside, but it needs to be left as a difference or a sum. Okay, you can combine angle to an angle inside of a cosine. So 5x minus 3x, you guys can combine that as cosine of 2x. And then this one as cosine of 8x, because that's just like adding 30 degrees and 45 degrees or whatever. But you guys cannot add like cosine of 2x minus cosine of 8x. You cannot make it like cosine of negative 6x or something, okay? That does not work. This is a side length minus a side length. You're not going to be able to do that. So this becomes your answer. It's 5 times the difference of those. And that is essentially two equal things. So you're just going from a product scenario to a sum or difference. And that's what we're looking for on that. And you just leave it like that. That's the whole problem, okay? So if you look at this one, this same drill, except now I have a cosine and a sine. If you guys go to your formula sheet, we have cosine first, then sine. So that is actually the very bottom one on your salmon sheet, and that'll end up equaling, and I just write down my formula, and I'll worry about the rest later. Sine of a plus b minus the sine of a minus b. All right, and I know that 3 pi is a and 1 pi is b. And if I just plug this in, I end up getting 1/2 of the sine of, we have 3 pi plus a pi, minus the sine of 3 pi minus a pi. And then now, since they're in parentheses and these are just angles, you can put them together as what? 4 pi minus the sine of 2 pi. Okay, now here's the deal. If you guys have angles though and you actually can find them, you should. Okay, so this is a difference. This is technically your answer in the difference, but if in the last problem I had x's, you can't do anything. But at 4 pi and 2 pi, I know what the y value is at 4 pi and 2 pi. Because where are we at? At 2 pi, we're at 1, 0. What's the y value? 0. 4 pi, that's 2 times around the circle. That's also 0. So this is 0 and that's 0. Well, what's 0 minus 0? 0. So when you multiply everything together, what's all that work to get an answer of? That's nothing. It would end up being 0. And if you went back up here and you guys noticed that, okay, what's cosine of 3 pi? Okay, where is cosine of 3 pi? You need to, you could do the exact same idea there. Okay, so that's kind of the idea behind it and what you want to do with that. Okay, just sine of pi is also 0. So anything times 0 is 0. So that is why that happens. So there's 2 examples of a product to sum answer. Now the other one we're going to do, this one's a little more, I wouldn't say it's more difficult, it's just a little bit more to the formula. If I give you a sum, so like this to that, and you need to put it into a product, okay? These are on the very bottom middle part of your salmon sheet. And what I want to do is, and it'll say this, rewrite it as a product. Okay, what you need to do is initially go find, once again, this is your A and your B. We've done that before, or your alpha and your beta. And what you need to do is say cosine and a cosine. Where's cosine minus cosine? So on your salmon sheet, that is the very, very bottom. All right, and you need to just, once again, you write it down. Find the formula and put it on your paper. So I go minus 2, and then it's the sine of, and then it's what, A or alpha. I'm going to go A minus B because you guys hate Greek for whatever reason. And then times the sine of A minus B over 2. Well, your A is 5x and your B is 3x in this problem. Okay, so it's negative 2 sine of 5x plus 3x over 2. And then the sine of 5x minus 3x over 2. And if you guys now simplify that out, you get the sine of, what do we have on top? 8x. Well, what's 8x divided by 2? 4x times the sine of 2x on top was 2x divided by 2. Just 1x. And you're done. Okay? So it ends up being negative 2 sine 4x. Oh, I have 2 sines in there. Times the sine. We only need one of those in there. My bad. That should be a times sign in there. Okay? So it should be negative 2 times 4x times sine of x. So I went from a difference to a product given that formula that I know cosine minus cosine. So same idea here. Now when you guys look at this though, what's sine of 75 minus sine of 75? When you first look at this, what should your answer be? That better be 0, but I want to show you via a problem or your formula why that's the case. Okay? So in this case, I have a sine minus a sine minus sine. It's the second one on your paper. So it end up being, here's your formula, 2 cosine of, it's A plus B over 2, sine of A minus B over 2. All right, so if I now dump this stuff in, here's my A, here's my B. That'll always be in the same order. And I end up going 2 cosine of 75 plus 75 over 2. And then sine of 75 minus 75 over 2 equals 2 times, this is just cosine of, that's going to be 150 divided by 2 gets me back to 75 degrees, times the sine of 75 minus 75 is 0. 0 divided by 2 is still 0. And since you have angles, if you guys ever have angles, pies or degrees, you should actually evaluate it because you can. Sine of 0, we just talked about that with the 2 pi. Okay, the sine is the y is 0. So 2 cosine 75 degrees, my bad, 75 degrees, times a 0. Well, anything times 0 is 0 once again, which that should happen when we knew that it was going to be 0, but that's why. That's showing you via the formula why that happens. So you may be asked to evaluate or rewrite expressions just like that. All right, there's 2 more. I want to verify an identity. All right, so in order to do that, you just need to go through cotangent, okay, equals this mess. Well, how do you verify something? You got to plug it in. Verify means I can just figure out this part. Give me a formula for that. Cosine plus cosine. All right, where can I go to figure out what that would be? Cosine plus cosine. If you look at your sum to product formulas, it's the third one down. All right, and it ends up being 2 times the cosine of, and I'm just going to do this all in one step, A plus B, so it's 3x plus x over 2. And then it's cosine of A minus B. Just trying to save myself room. Okay? All over. Then I'm going to go in red for the bottom one here. Sine minus sine. So that's the second one up. And that's going to be 2 cosine of A plus B. And then this one will be sine of A minus B. Okay, now if I simplify or dump all of this stuff together, What do you notice? If this is all multiplication now, everything's free game. So 2 divided by 2 is 1. What do you guys notice about this right here? It's exactly the same. This is 4x over 2. So this is cosine of 2x, and this one's also cosine of 2x. They cross out. This whole thing is gone. So what are you left with? You're just left with this fraction on top, or essentially this cosine on top, which is, let's see, 2x over 2 is just cosine of x on top. And then this would also be 2x over 2, so just sine of x on the bottom. And we all know by now that cosine over sine is indeed cotangent of x. So that's a way, if I ask you to verify, it's going to be true. It's just a matter of you finding the right formulas, plugging the stuff in, and just simplifying down to make it show up. Okay? So it's not necessarily a proof, it's just verifying the identity. So that's why I did that way. And the last one, it says, evaluate without using a calculator. All right, so what does arcsine and arctangent mean? Okay, that's like saying sine inverse and tangent inverse. That means that this technically is an angle. Okay, it's some angle measurement. That's what we need to take out of that. So I'm going to call this angle A and this one angle B. And we'll worry about that later, and we'll kind of see what that happens. But this is essentially saying it's cosine of A minus B. And I want to evaluate that. Well, do I have a formula that lets me? This is actually going to kind of take us back a little bit. Where do I know that cosine of A minus B is? This goes back to like the very first section of this chapter. Okay, we need to go back to our sum and difference formulas. The cosine of A minus B is actually equal to cosine A cosine of B. And the reason I'm doing this is you guys need to make this connection and be able to jump back and forth between these sections on a test. You have to recognize that, okay, cosine of A minus B, that's a sum or difference formula. I need to go to my sum or difference formulas and find this, okay? And now cosine A, and I need cosine B. I need to find a triangle or build a triangle for A. Here's my A. And then another one for B. Okay, what do I know about A? This is A. The arcsine is 3/5. So if it's positive, sine inverse is positive in quadrant 1. All right? And my sine is 3/5, which means my other side's going to be a 4. Okay? My angle B measurement, I know tangent inverse is positive, so that's also quadrant 1. And it's 2 over 1. Tangent is 2 over 1. What will that make my hypotenuse? 1 squared plus 2 squared was that 5. So the square root of 5 if you do your Pythagorean theorem. Okay? And the reason that this is beneficial now is now you just need to go cosine of angle A. Well, here's angle A. What's my cosine? 4/5. Times. What's my cosine of B? 1 over the square root of 5. Actually, we could make that a little bit simpler and just actually do that right now. What's 1 over root 5? What should it actually be written as? Root 5 over 5. Okay? Plus sine of A. What is that going to be? Sine A. So 3/5 times sine of B will be 2 over root 5, but I can write that as 2 roots 5 over 5. Okay. So if I multiply this stuff together, I get 4 root 5 over 25 plus, if I multiply the top together, what is that? 6 root 5 over 25. And now since I have a common denominator, I can add these together. So 4 root 5 plus 6 root 5s. 4 of them plus 6 of them is 10 root 5s over 25. And what goes into both? 5. So 5 divided by, or 10 divided by 5 is 2 root 5 over 25 divided by 5 is 5. And that would be your answer. Okay? So there's a way of using many different formulas and many different things that we have learned throughout this section. The assignment actually was on the bottom right there. And we will work through that in class and try to do some more problems and all that stuff. So I hope you all have a wonderful day.